Okay, so let's look at this one. It's asking us whether this proof is correct or not. Okay, let's go over the proof. First of all, we are assuming that m is a natural number bigger than 1, and x and y are integers, and we have this equation here, which says that x to the 4 plus y to the 4 equals 2 times x squared y squared mod m. And we want to deduce that x equals y mod m or x equals minus y mod m. Okay, so let's see what the proof says. First of all, this is just a repetition of the assumption, so nothing wrong with this part. Okay, we subtract 2 times x squared y squared from both sides of this equality, which is an equality mod m. Subtracting things mod any number is a valid operation, so nothing wrong with this part. So we have x to the 4 minus 2 times x squared y squared plus y to the 4 equals 0 mod m. Okay, how about this factoring part? Can we factor things mod m? Well, yeah, basically. It's easier to see how this is equal to this one. So let's see yx squared minus y squared to the 2. Well, if you expand this out, you see that it's equal to x to the 4 plus y to the 4 minus 2 times the terms inside of the parentheses, which are x squared and y squared. So it's minus 2 times x squared y squared. So as you can see, this is an equality in real numbers, so it must also hold mod m. So this thing is equal to this thing in real numbers, and so it's also equal to it mod m. Okay, so this part was valid. Okay, what about the other? What about the next step? We are taking the square root of both sides. Okay, this is the part where we see our first problem. Can we take square roots mod m? Well, as it turns out, no, we cannot do that. To just give you an example, let's say 0. Let's say x is equal to okay, so first of all, let's forget about this problem for a moment. Let's assume that we have two numbers a and b, and a is equal to 2 and b is equal to 0. Okay, then what is a squared? Let's also assume that m is equal to 4. So when we are working with this setting, what is a squared? A squared mod m is equal to 4 mod m, which is going to be 0, right? What about b squared? Well, we have b squared equals 0 squared, which is 0, also mod 4. So we do have the fact that a squared is equal to b squared, mod 4. Right? But from this, we cannot deduce the fact that a equals b mod 4. Right? Because as you can see, a and b are in fact not equal to each other mod 4. A is equal to 2, b is equal to 0. So this part is where we have our first problem. Okay? Taking square roots is not always a valid operation. Okay, so how about the next part then? Well, this is just adding y squared to both sides, which, as we said, is a valid operation. So this part is also fine, but at the end, we again take the square roots mod m. Okay, here we are a little bit more careful, and notice that when two numbers are equal mod m, they can be either equal to each other or negative, or one can be the negative of the other one. Well, this covers a little bit more cases, but as we said again, this is not a valid operation. Okay, the same example holds here. So for example, reverting back to our own example where m was 4, a was 2, b was 0, again you see that a squared is equal to b squared mod m, but it does not hold that a is equal to b mod 4. Everything is mod 4. And it also doesn't hold that a is equal to minus b mod 4. Okay, so this is not valid, this is not valid. So we cannot deduce from a squared equals b squared mod something that either a is equal to b or a is equal to minus b mod that thing. So again, this is the second error in our problem. Okay, so the answer, so the grade we are gonna give this proof is F, and we have found two errors which make us give this grade.